The 10th question that we have is a typical problem. We have two parts. Let us solve the first part first. We have all the wires having equal distances R. We need to find out the R equivalent between A and B. So for finding out the R equivalent between A and B, imagine that you are putting up a cell over here. Now when you put a cell, current will go into this wire and this wire. These two wires are exactly equivalent. Again, these two wires are exactly equivalent. There is no biasness between these two wires. Therefore, same current will go into these wires. Now for these two wires, this wire is common. Now when the current will go from here and from here, it is equal chances of going from here to here and here to here. That is what I mean to say, that there is no biasness in any direction for the current to flow in either this direction or this direction in this wire. If you carefully visualize and imagine the figure, the current goes from here, splits into these two because these two are exactly equivalent because they have the same resistance. Now both will try to send current into this wire. So equivalently, what will happen actually is that no current will flow through this wire because there is no biasness for the current to flow in a particular direction. If we suppose we take the case of this wire, this may have a biasness because we have a cell like this which is producing a biasness in this clockwise direction. But for this wire, there is no biasness in either direction. Therefore, there will be no current flowing through this wire, and therefore a wire through which current does not flow can be removed from the circuit, as we already know. Now similar is the case with wire CE, if you imagine it. Therefore we can remove wire CE also. Now it becomes very easy to solve for the resistance. The figure now can be written as this resistance become equal to 3R. This resistance is R and this resistance is again 3R. So the equivalent resistance becomes equal to 3R and 3R become equal to 3R by 2. And we have 3R by 2 and R in parallel. Therefore it becomes 3R by 2 into R upon 5R by 2. That is equal to 3R upon 5. So our answer for the R equivalent in first case comes out to be equal to, in the first part comes out to be equal to 3R upon 5. Now let us solve the second part. In the second part, we have a voltage source V. This is a resistance of 1 ohm, 2 ohm, 1 ohm, 2 ohm, and this goes on like till infinity. We need to find out the current through this 2 ohm resistor. Now, this is a very typical question. You must know how to solve this. A question of this type actually came in JEE also. This 6 volt cell is there. We have 1 ohm resistance over here, 2 ohm resistance over here. Let the equivalent resistance of this whole circuit be R equivalent. I have assumed the equivalent resistance of this whole circuit to be equal to R equivalent. Now the whole circuit from here to here is the same as from here to here. Therefore the equivalent resistance of the circuit across these 2 points will also be equal to R equivalent, because infinity minus 1 is infinity. Therefore we can assume R equivalent attached over here. Now the equivalent resistance of this circuit will also be equal to R equivalent. Therefore 2 into R equivalent upon 2 plus R equivalent plus 1, this will be equal to R equivalent. So now let us solve for R equivalent. We have 2x upon 2 plus x plus 1 is equal to x. Therefore we get 3x plus 2 is equal to 2 plus 2x plus x square. That is x square minus x minus 2 is equal to 0. On solving this, we get the values of x as minus 1 and 2. Now R equivalent cannot be minus 1. Therefore R equivalent is equal to 2. Therefore in this infinite ladder that we have, our question becomes very simple now. We have converted this system into 1 ohm, 2 ohm and 2 ohm, which is in parallel to this 2 ohm. Now the current, R equivalent of this 2 ohm and 2 ohm will be 1 ohm. Therefore the total current through this circuit will be equal to 6 upon 2. R is the R equivalent. This is equal to 3 ampere. Therefore 3 ampere current is coming from here. It will distribute equally in these two channels because these two resistances are same, 1.5 ampere each. Therefore the current through this 2 ohm resistor will be equal to 3 by 2 amperes. So in this question we learned how to solve for current and other things. We can also find the voltage and everything else in the case of an infinite ladder. So the final answer in this case comes out to be equal to 3 by 2 amperes, and in the first case the R equivalent comes out to be equal to 3 R upon 5.